Alright, so what we want to work on right now is solving exponential equations. So an exponential equation is obviously written in exponential form. So let's say we have 7 to the 3x power equals 20. Alright, and we want to find the value of x. Well, just looking at that right there is probably enough to make you want to scratch your head and say, oh my gosh, what do I do? So luckily we've been studying logarithms, and we're going to use the logarithms to help us solve for x. So your first step is to simply write log in front of both values. We're going to write log here, we're going to write log here. Remember, your logarithms are the inverse of your exponentials. Okay, so basically what we've done by writing the log here is we are in the process of taking the inverse of that original equation. Okay, so far so good. We've written the log. Now let's continue and see what happens. Now, if you think back to your properties of logarithms, anytime you have an exponent, you have to take it and move it down in front. So that's our next step. Take your exponent of 3x, move it out in front of the log. Okay, so now both sides of our equation are written in correct logarithm form. And so what we're going to do now is simply do some algebra and get our x by ourselves. Now, the log of 7 part has to stick together. And now that we have 3 in front of that, we're multiplying. So all of this goes together except for this part right here. This is 3 times x. So what's the opposite of multiplying? Dividing. So what we're going to do is we're going to divide by everything except for the x, okay? Because we want to leave that alone. So we're going to divide by 3 log of 7. Okay, so you notice all of this is together. And what you do to one side, you got to do to the other. So we're going to divide over here by 3 log of 7. And this is where your calculator comes in handy. So our x is going to equal whatever that equals. So you'll notice our base is a common log, so our base is 10. So luckily in our calculator, wherever you see the log button, which is right down here, okay, that's automatically your common log. Okay, so anytime you use the logarithms in your calculator, remember that it is a log base 10. Luckily, most of the time when you're going to solve an exponential equation or a logarithm equation, it's going to have a base of 10 anyway. Okay, so shouldn't have too many issues there. So all I'm going to do is type into my calculator exactly what I had simplified down to. So log of 20 divided by 3 log of 7. Okay, now this is a valuable lesson. You see how we get this 0.366? That's not right. Can anybody guess what needs to happen with our denominator when we type this in? You're right. We need to make sure that we put an extra set of parentheses, because what I just told the calculator to do was log of 20 divided by 3 times the log of 7. So I told my calculator wrong. Remember, your calculator is not as smart as you are. So let's try this again. Log 20 divided by, okay, I remember my parentheses this time, 3 log of 7, close both sets of parentheses, and this time I get the correct answer, which is 0.513 blah, 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 blah. Okay, so my x equals 0.513. Now, the way you check this is to plug it in back to our original equation. So substitute into your calculator 7, and I'd use some parentheses here, to the 3 times 0.513 power, and let's see if it gives us a number close to 20. So 7, oh, there we go, now we can see it. 7 to the 3 times 0.513 power, we get 19.98, which is pretty doggone close to 20. Remember, we rounded just a little bit that 0.513 number. We rounded that a bit, so that's why it's not a perfect 20. Okay, but luckily we worked that out and got that correct. Let's do another one. Let's try something like 3 to the x power equals 4. Okay, well, 3 to the what power is going to give you 4. Remember, you start by simply beginning the process of inversion, I guess you'd say. Okay, so we're going to do log of 3 to the x power equals log of 4. Okay, and then using our properties of logarithms, remember when we have an exponent, we need to bring that down in front. So x times the log of 3 equals the log of 4. And now we're trying to get our x by itself, so we're going to divide by the log of 3. And now we simply substitute that into our calculator. Remember, parentheses, parentheses, parentheses. Let's clear that out. So I'm going to type in, we'll just go ahead and put parentheses on top too, since we're trying to be cautious, I guess. Divided by the log of 3. Bam, you get 1.2619. Okay, you'll notice that in this one I'm going to go couple more decimal places. Remember, the more decimal places you use, the more accurate you are. So again, we want to check our work. So let's see if 3 to the 1.2619 property, and it does give me 4. So that's our correct answer. We have enough time to do one more problem. Let's see what we can do here. Let's try one like 6 to the 2x power equals 21. Again, start by inversion. Log of 6 to the 2x power equals the log of 21. Bring your exponent down in front. Okay, now we remember we want to divide all this stuff. Okay, divide by all of this stuff except for the x. Leave the x by itself, right? Okay, so we're going to divide by the 2. Mark that out. Log of 6, and divide this side by 2 log of 6. We're left with x equals. Now let's throw everything into the calculator. Kind of rushing here because I got to get under my 10-minute mark. Okay, so log of 21 divided by parentheses 2 log of 6, and we get 0.8495. Again, let's substitute it in. So we're doing 6 to the 2x power, so substitute, replace the x with 0.8495. And we get 20.99, which rounds up to 21, which is what we were aiming for there. So it works. Okay, so there's a few examples to play around with and watch. Good luck.